Chapter 10, number 71. Two blocks, as shown in figure 1071, are connected by a string of negligible mass pulling over a pulley of radius .250 meters and moment of inertia I. The block on the frictionless incline is moving up with a constant acceleration of 2 meters per second squared. A. Determine T1 and T2, the tensions in the two parts of the string, and B. Find the moment of inertia of the pulley.
In the figure, we can see that block 2 is pulling block 1 over the pulley, and it's making it accelerate at 2 meters per second squared. In this problem, we're given that the radius of the pulley is 0.25 meters, and the angle of elevation is 37 degrees, and there's no friction, and the mass of the pulley and things are negligible. And also, the blocks are accelerating at 2 meters per second squared. And in this problem, we're asked to find the tension in pulley 1 and tension in pulley 2, or tension in rope 1 and tension in rope 2. And we're also asked to find the moment of inertia I of the pulley. So to start this out, we'll look at the block 1. This is the free body diagram. You split the tensions going up, and then you split the downward of the mass into mg sine 37 degrees and mg cosine 37 degrees, and we can just ignore the cosine 37 degrees because that doesn't matter. So then we look at this problem, we use the sum of the forces is equal to the net force. So we can see that the tension 1 minus mass 1 g sine 37 degrees is equal to just mass 1 times its acceleration, since that's the net acceleration. And so we can simplify that, so tension 1 is equal to m1 acceleration plus g sine 37 degrees. And we can plug in the numbers, so 15 kilograms times 2 meters per second squared plus 9.8 times sine 37 degrees is equal to 118 newtons. That's tension 1. And so we do the same thing for the block 2. This is the free body diagram. It just has tension upwards and the mass times gravity downwards. So this one's pretty simple. We use the sum of the forces is equal to force net again. And we get m2g minus t2 is equal to m2 times its total acceleration. And we can simplify that. So t2 is equal to mass 2 times gravity minus acceleration. We can plug in the numbers to get 20 kilograms times 9.8 minus 2 meters per second squared is equal to 156 newtons. That's tension 2. So then for part B, we're trying to find the moment of inertia, so we use the equation tension 2 minus tension 1 times radius is equal to moment of inertia times angular acceleration alpha. So then we know that alpha is equal to the acceleration not centripetal divided by radius, so we can plug that into the formula. So we get tension 2 minus tension 1 is equal to moment of inertia times acceleration over r, and we can solve that. So we get moment of inertia is equal to r squared times t2 minus t1 over acceleration, and we can just plug in the givens. So we get 0.25 meters squared times 156 minus 118 newtons divided by 2 meters per second squared comes out with the final answer of 1.17 kilograms times meter squared.